And then one other thing, so I know when you came in, I also had the assignment for you to pick up, and the reason for that is we have one example, or rather the first example, where we're actually going to go through and use the calculators to calculate this probability. Since I don't have any additional examples of just that before we get into the second example, I'll probably have you refer to at least one of the problems on the worksheet to just get you started on some practice to make sure you're able to calculate these values on your own. So that's why I had you pick that up right away. Any downtime where I'm helping people with their calculators, anything like that, you have the assignment already that you can start practicing. Just make sure then when we pick up with the next example that you tune back in. But today we are still, this is kind of the final lesson with binomial distributions. Here we're actually calculating a probability based on a binomial distribution. So we have already worked with identifying if something is a binomial experiment, conducting binomial experiments. So today we're going to be identifying very similar information. For example, we're identifying how many trials do you have, what's the probability of a success, of a failure, but then we're using it to actually do a calculation. So I have at the top, it says, it's kind of referring back to an example we did on Friday. In an experiment, such as drawing an even-numbered card from a deck of cards. So if you think back to Friday, we did that simulation of 52 trials. It says after 52 trials, there may be any number of successes from 0 to 52. And each time the experiment is conducted, a different number of successes may result. So this situation then can be represented by a binomial distribution. A binomial distribution is a frequency distribution of the probability of each value of x, where the random variable x represents the number of successes in n trials. We've talked about that already. And then it says because x is a discrete random variable, a binomial distribution is a discrete probability distribution. So this information here, you don't need to memorize this formula. You need to know how to use it. But this is very important in this lesson. So this is how you calculate probabilities in a binomial distribution. And you need to know what everything means. So it says the probability of x successes in n independent trials is, this is your formula. And in this formula, P is representing the probability of a success. Q is representing the probability of a failure. And again, it does give below to calculate Q, you take 1 minus P. And then up above, I'm just going to highlight N represents the number of trials that are independent. And then you're looking for the probability of X successes. And in this formula, let's see, I'm going to talk about what's over here. So this first piece right here where you see the NCX, I have below what that actually means. So NCX, you may remember, I'm not sure, statistics I know in Algebra 1 is one of those chapters where it's if we get to it, we get to it. And if we don't, we don't. So you may have seen this notation before. This is calculating a combination. There's permutations and there's combinations. So NCX represents, or rather it's worded as N choose X. So it represents the number of combinations that can be made from N by taking X amount at a time. So it's basically the number of combinations that are possible. Combinations are calculated using this formula. So NCX represents this formula. However, you don't have to know this formula because scientific calculators have a combination function you can use as a shortcut to calculate the combination. So you don't have to calculate this. I do want to talk more about this, though. This is just something that could be helpful to you with future statistic questions. What does the exclamation point, what is that called in math? It's a factorial. And it's written after a number. So for example, if I have 4 exclamation point, 4 factorial, Darren, do you know what that means or how you'd calculate it? Yes, so it's that number multiplied by every integer less than that number all the way down to 1. So like 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So anytime you see an exclamation point in math, it's representing a factorial. But again, your calculator does this. Your scientific calculators do that. So that's where today there might be some time where I'm just helping you figure out your calculators. So we have the probability of x successes is equal to the number of combinations you would have choosing x out of n possibilities multiplied by p, which is the probability of success raised to the power of x. So it's the probability of success raised to the number of successes. And then q is the probability of failure raised to, and then n minus x, this is what's explained over here. N minus x would represent the number of failures in n trials. So it's your number of trials minus your number of successes. So number of failures raised to the power of the number of failures. Okay, so I am giving you the formula, but just understanding what that formula represents, that can be helpful. So let's look at an example of actually using this. So in example 1, it says, at Jenny's telemarketing job, 15% of the calls that she makes to potential customers result in a sale. She makes 20 calls in a given hour. What is the probability that 5 calls result in a sale? Okay, so I'm just going to highlight the actual question. Probability that 5 calls result in a sale. So I'm going to list off to the side what values we need to identify in order to substitute into this formula up here. First of all, I want you to recognize that this is a binomial experiment or a binomial situation. There's only 2 outcomes when she makes a call. Either it will result in a sale or it will not. And then what would the probability of a success be? What would the probability be that the call she makes does result in a sale? Or the value of P? What would the probability of a success be? 15%, 0.15. So the probability of each call is independent. Each call would have a probability of 15%. So we have to identify these following values, n, x, p, and q. And then I'm just going to write down, so I can move my sheet up here, I'm just writing down this formula in the problem, and then we'll fill things in. Okay, so n is your total number of trials. So what would n be in this situation? 20, yes, she's making 20 calls. X is what you're trying to find the probability of. X would be the number of successes. We want to know the probability that 5 calls will result in a sale. So our X value is 5. P is your probability of a success, that it will result in a sale. So we had already identified that was 15%, but you need to substitute that into the formula as a decimal, so 0.15. And then Q is the probability that it would not result in a sale, the probability of failure, which would be what? Yes, 0.85. So just taking 1 minus your probability of success, these two should add to be 1. So we're going to substitute these values into our formula. So we're finding the probability, or P of 5, the probability that 5 calls will result in a sale. And that'll equal 20 choose 5. So that would be the number of combinations you can get of choosing 5 out of 20. The probability of success P is 0.15 raised to the power of x, which is 5, times the probability of failure, 0.85, raised to the power of n minus x. So here, I'm going to write this just as one number right away. N minus x, so this would be the number of failures that would occur. So 20 minus 5, this would be raised to the 15th power. If you want to make a note. It's just when you type this in your calculator, you're going to want this written as just as one number. There's often mistakes that happen if students are raising it to a power of 20 minus 5. It's just not typed in correctly. So simplify that exponent before you type anything in. Okay, so that's the setup. And now the calculator does the actual calculation for you. So I'm first going to show you how to get this on your calculator. And this is where you need to make sure you can get the right values. So if you have a calculator like mine, you have a probability key. It's in the second column, second one down. It says PRB on it. If you click PRB, notice then, so this, the NPR, that would be a permutation. We're not working with those. So NCR, so I know ours says NCX. It means the same thing. We have X in our problem. They have R on the calculator. So you want NCR for a combination. You also have that factorial button if you ever needed that. So what I need to type in first, I'm actually going to be exiting out of this screen. When I type this in, I want to type in my N value first, then click this key, then type in my X value. So this is how it's going to look like. I'm going to type in 20. Then I'm going to go to that probability, go over to NCR, click enter. So I want the 20 in front of it, and then I want 5 after it. And then click enter, and it'll give you that value. Now, this is an actual whole number value, which if you wanted to, you could mark down what that is. I want you to make sure, though, you're not rounding anything till the very end. So I'm actually just going to keep this value stored in my calculator. What I will do, though, is write it down. So if you're not getting this value, in a moment here I'll walk around. I can help you make sure you're able to get it. So if you're not getting 15,504, I'm going to walk around momentarily and make sure I can help you figure out your calculators. But I can then leave that typed into my calculator because now this is multiplied by the following. So leaving that typed in, I'm just going to then type in times. And then I don't really need the 0.15 in parentheses. I could put it in parentheses, but I'll type in 0.15 raised to the 5th power. And if I wanted to, I could hit enter again right after that. Again, leaving that in my calculator, and then hit times, and then 0.85 raised to the 15th power, and hit enter. And this would be the final answer. So if you're not getting this, again, momentarily, I'll walk around. I can help you out on your calculators. So I'm going to write this down. So I just want to make sure you're not rounding any values. I don't want you to type these all in separately, and if you get decimals, round them and then multiply, because that's going to change how your answer is rounded. Round at the very end. So I would round this to at least 3 decimal places. So 0.103, because what this represents, the 0.103 means there's a 10.3% chance that 5 calls will result in a sale. Okay, so that is the answer to the question. What's the probability that 5 calls result in a sale? 10.3% chance. Okay, any questions on that? Okay, so for right now, before we move on, I'd like everybody at the very least, if you get done with this, you can keep working. But on your assignment sheet, I want you to do problem number 1. So I want you to calculate that probability. I'm going to walk around. If you were not able to get the correct answer for example 1, let me know. If you're having troubles with your calculator, let me know. Because I know different calculators work differently. Most calculators, I think, were okay. So here, double check for number 1 on the assignment. You should have gotten approximately 18.3%. So N is 12, X is 10, probability of success 92%, so 0.92, leaving Q to be 0.08. Substitute that in, 18.3%. And then this was a question as I walked around as well. Between N and X, N should always be bigger because N is your total number of trials, X is a certain number out of that many. So if you are getting your X to be bigger than N, you have them switched around. Okay, any questions on that first one on the assignment? Otherwise, we're going to move on with example 2 on the actual note sheet. Okay, so that's calculating a probability from a binomial distribution. Actually, at the bottom of that front page, it says, this is relating to example 1. So it says, if on average 15% of the people Jenny calls make a purchase and she solicits 20 people in an hour, then she can probably expect to make 3 sales, 3 coming from just multiplying 20 by 15%, or 20 times 0.15. So this value represents the mean of the binomial distribution, which is calculated with this formula. So the mean of a binomial distribution, which could also be, it's usually phrased in a problem, how many could you expect to happen? So what's expected to happen? So the mean, which is called mu, of a binomial distribution is given by this formula. You take your value of N, your total number of trials, multiply that by your probability of success, and that is the mean or the value that you could expect to happen. Here? Nope, this is mu. It's that Greek M. So mu is equal to N times P. Yes, that two-way. Okay, so we'll be using that as part of the next problem. Now at the top of that second page, this is actually finding a probability distribution for a binomial experiment. One way to find this is by fully expanding this binomial that has this long calculation. You do not need to do that. I just included this information, but that's not needed for what we're doing. But why we would use a probability distribution, it's helpful when you're solving for problems that allow multiple numbers of successes. So in the previous example, we were looking for the probability of specifically 5 successes. This would be used for a problem where there's not a specific number of successes and the number of successes could be different values. So example 2 says a family has 4 children. Assume that when a child is born, there's a 50% chance that the child is female and then 50% the child is male. It says determine in part A the probabilities associated with the number of daughters in the family by calculating the probability distribution. Okay, so what you first have to come up with, I have a chart to help us out. The number of daughters, these are the possible values of X, your random variable X. So this is saying there isn't a specific number of successes. X could be different numbers. If the family has 4 children, how many possible, or what possible numbers of daughters could that family have? They could have 2. They could have 1, 0, 3, or all 4 children could be daughters, right? So that's why X has different values. If they have 4 children, you could say all 4 children could be daughters. Maybe only 3 are daughters, maybe only 2, maybe only 1, or maybe all are sons. They don't have any daughters. So x has 5 different possible values. Okay, that means there's 5 different probabilities. What's the probability that all 4 would be daughters? What's the probability that only 3 would be daughters? So these probabilities then, you're calculating using this formula. But you have to do that 5 different times because we have 5 different values of x. So I'm just going to rewrite the formula up here just so we have it in front of us. This is from the front side. Okay, and some calculators, if you have to do this calculation multiple times, I'll show you on my calculator. Some calculators make it easy to get multiple values. Other calculators, I know when you're typing things in, you might have to keep retyping things over and over. So first of all, these are all the different values of x, but the values of n, p, and q are the same for every value of x. So in this situation, what is the value of n? 4. There's 4 children. What's the value of p? 0.5, 50%, and then q would also be 0.5. Probability of success and failure would be the same. So then what changes is the x value. So I'm first going to calculate if the x value is 4. This would be our calculation. We would have the probability of 4 daughters equals 4 choose 4 times 0.5 to the 4th power times 0.5 to the n minus x. In this case would be 4 minus 4, so that would be to the 0 power. Okay, so I could type this in actually all in one line on my calculator. Now, some of your calculators, you're not able to do that. So this is what I would do if I'm calculating multiple. I would type in the 4 choose 4, so 4 and then probability, arrow over to the combination, hit enter, 4. Actually, you might have to type this in. I'll just type it in not all as one line. I could put this in parentheses if I wanted to. We'll just do this. So 4 choose 4 is 1, and then times 0.5 raised to the 4th power times 0.5 raised to the 0 power. So 0.0625. So you could either put the decimal itself, and I know I said round at least to 3 decimal places, 0.0625, since it's a terminating decimal, I'm just keeping the whole thing. But what this means is there's only a 6.25% chance that all 4 daughters would, or all 4 children would be daughters. Okay, and then we would do that same thing for these values as well. So actually, what I'm going to do is I'm going to freeze this. I want you to do these calculations, and then I'll unfreeze it. Just make sure that you've gotten the right calculations. So here's some more practice with using that formula. So calculate the probability for 3, 2, 1, and 0. And I'll do the same up here. Oh, the... Yep. Hey, Danica, can you bring your calculator up here? So it says you want to type in, so like say 20 choose 5, so 20. Oh. How did I not see that before? There it is. It was, okay, how do I go back? Just meant, like, if I just want to go back to the regular, or, oh, exit, okay. So you hit this, and then go over, you want probability, and then there it is. So it'd be 20, and then 5.
Oh, okay, thank you.
Yep. Okay. Here I just want you to double check, and after we get through this, if you're still having trouble, you're not getting these values correct, then please let me know with the work time we have. So either you should have the decimals, or if you just have the percents written in, that's fine. You don't have to have both. Okay, so again, if you are not getting these values on your calculator, when we have time to work here, make sure that you ask. Okay? So that's how you fill in, or rather make a probability distribution, is you come up with what are the possible numbers of successes, and then you do this calculation for all of those different x values. And again, your n, p, and q would be the same for all of them. The only thing changing is x to get each probability. Part B then says, what is the probability that the family has at least 3 daughters? Okay, so first of all, what does at least 3 daughters mean? How many daughters could they have if they have at least 3? 3 or 4? Okay, so here's how you calculate this. You already have the probability that 3 daughters will be, or 3 children will be daughters. You also have the probability that all 4 children will be daughters. All you do for this is you take the probability of 3 daughters and you add it to the probability of 4 daughters. Those two probabilities added together will be the probability that at least 3 will be daughters. So you would take the 0.25 and add it to the 0.0625, and that is 3.125. So you could leave that as a decimal or say there's a 31.25% chance they will have at least 3 daughters. Okay, so that's just more of make sure you interpret that correctly and know which probabilities you are adding together. Any questions on that one? Okay, and then part C, it says how many daughters should the family expect to have? The expected value, again, that's when it's talking about the mean that we had talked about that formula on the previous side. The expected value, that mean mu, is equal to your number of trials, in this case the number of children they have, multiplied by the probability of a success, the probability they would have a daughter. So if they have 4 children and there's a 50% chance their child will be female, they would expect that 2 of those children would be daughters. So how many daughters should they expect to have? 2. Now, I do want to say, though, this is how this value is calculated. You do not answer this question by looking at your table and choosing the highest probability. Okay, now in this case, the highest probability is when there's 2 daughters. That is not the reasoning, though, for why this answer is 2. So that's not always the case where the highest probability up here is what you would expect to have in this question. So make sure you are doing this calculation when it asks you what's expected. Okay, any questions on that? Okay, so we have about 6 minutes. You already have your assignment. Please continue working on that right now. Any of those problems could be on the homework quiz Wednesday. If you have not practiced using your calculator to do these calculations, you probably won't get those questions right on Wednesday. So make sure you're practicing this. Use the time you have right now to keep working on it. Let me know if you have questions.